Hello everyone, welcome back. This is Jim Lewis at Model Train Technology. Well, today's the day. We finally got there. We're announcing our G-Scale signaling system. We have other G-Scale products on the way, but we wanted to start with this. We're so jazzed. We moved over to our house because we have what's called a Florida room in Orlando, Florida. It's a big concrete slab with a screen over it, and we have a G-Scale layout running around that. Here's our Union Pacific engine. It's battery powered. We run it on that. We're going to show you that in just a second. One of the challenges, of course, outside is the sensor, and we pioneered the notion of the precision sensor, and the one that we use for N-scale and HO is about 5.5 inches, and that'd be pretty close. That would work, but we wanted to have something more robust and allow more flexibility. So we worked very hard. It took us a year actually to work on the sensor and all of the electronics. I'll show you how they're configured. One runs on battery, and the other one can be powered by 12 volts DC. But anyway, let's show the signals in action, and then we'll come back and I'll show you how all of the configurations are set up.
Lock signals clear.
So let's show you how all of the signaling is set up. You may notice that I have these big rubber blocks here, and these are actually, I found these on Amazon. They're jeweler's pads, and they're used for hammering different jewelry pieces. For our setup, when we have a big slab and we just want to lay these down, this worked out great. It's heavy relative to its size. We drill holes in and we provide these little rubber, these are 3D printed pads. Rubber on the hot concrete would start to color and fuse with the concrete. So these resin pads keep it off the cement. Even though it's painted, it does leave a mark. Without that, without the pads, but with the pads, there's no problem. We pioneered, this is our O-scale sensor. You may have seen this before. Here's the sensor in the back, and it comes with an electrical case. This sensor, we've upgraded this sensor to the outdoor scale, so it has about a 1 meter range. Now, low to the ground, remember that this sensor beam that goes out spreads out as it goes out. So we need a little height here, but you can use these small sensors up close if you want to connect them. So there's a sensor in the two configurations here. This is the powered one. In other words, it requires 12 volts to come in to run it, and you can just slide this off and you can see the electronics. So what we've done is we've combined the signal controller with our sensor onto one board. So there's actually a sensor mounted on the back side of the board, and there's a little hole in the case so that when this slides down over it, the beam can see the train. On the inside, you can wire up a variety of block signals. So right now we have two. We have the 7 light signal, and then we have the 3 light signal. And these functionally are the same as what you've seen in the N-scale and HO. If you want a full description, go to our video. There's a link at the bottom of this video to see our signaling video that we did about a year ago. It goes into great depth of that, but we'll talk about most of that here today. On the board here, there are 3 trim pots, one to adjust the speed of going through the stages, so you can see the light will change. Let's see if we can trigger that off. There we go. And it'll go through from green to red to yellow and back, so you can speed up or slow that down. The second trim pot is for the timeout of the sensor. That is, after the train has passed the sensor, how long does it stay on until it starts the color changing sequence. And the last sensor, the last adjustment you can make is the distance. And we have played around with this quite a bit, and we think that up to about 18 to 20 inches is a pretty good distance before you start hitting the sensor starts seeing the track itself as opposed to the engine on the track. You can solve that by just raising the sensor a little bit, and that cone of vision will raise up. But that's a pretty good distance. I would think most of our situations, we did it inside of a foot, and it worked great. What also is amazing, it works at night in any light condition. And the other day, we pointed it, the sun sets behind me, we pointed this directly into the sun as it was setting, and it worked great. It's just amazing. So we're pretty excited about that, that setup. So now, this, as I said, this is the one that's powered. I actually am powering it off a battery. And this is the inside of what this looks like. We'll take this off in a second. But in this case, we designed the battery pack around a lithium polymer battery. This is called a short. And this one has 5,000 milliamp hours. So figure that it uses 50 amps per hour for running it. So you've got, I don't know, 10, 12 hours of use with the lights fully on. This does have an automatic shutout, which you can turn on and disable or enable. In other words, after an hour, the lights will go off. In other words, nothing passed in front of the sensor, the lights will go off to save a little current. So if the trains are not going by frequently, that might be a way to go. As soon as a train goes by the sensor, the lights come back on automatically, and it will stay on for an hour and follow those aspects. So anyway, here's the battery. You can buy them. We're not going to sell these online because we'd end up shipping LIPO, this is what they're called, lithium polymer batteries. And so what we're going to do is have a link to the Amazon site where you can buy both the batteries in packs of 2 or singles, as well as the charger. There's a variety of chargers. We tested them. It's really simple. There's a fast charge mode, which will charge it in less than half an hour, and then an overnight mode. Pretty cool battery. It's a really great one. So the way this works is we built the circuit board to slide into the banana plugs on the battery. So these come, this is the way the board comes, and you just take this, and in fact, this board right here, I have plugged into these lights. So there's a power outlet. So the battery that I have here was powering both this board and this board. And the way I do it is just plug it in. I'm going to put the wire in between the wires just for keep it clean. Turn the battery on. The sensor will blink 4 times very rapidly to say it's up and running and ready to go. And then this slides into this sleeve that we made. And the sleeve can either fit the bumpers for just putting out on the layout like that, or you can remove the bumpers. They just pop off. And if you want to super glue them on or glue them, whatever. But then also this provides a nailing hole if you want to put it into the ground. And so what we've used is, not here because we've got concrete, but in our test out in the other part of the yard, we used aluminum nails and just pushed them into the ground, and that kept it sturdy. So that's the sensor. Now, on this one, we're just using this for power right now. So let's see, if we back up and running, yep, great. Okay. So this is the 3 light sensor. You can run it with the red lights, the center light off for red, or with the center light always on. Also with the HO and N scale, customers asked us for different lighting patterns. So one customer has red on the sides, no center light. He asked us to make, so we have a version with no center light, 2 reds, 2 yellows, and 2 greens. That's fine. We're happy to do that. We will sell the mounting block and the magnets that come with it. Remember, we have the magnet system, so you can easily knock this over and not break the unit. This is an aluminum pole here and 3D printed. We included in the kit is a template for locating the hole. If you wanted to drill this or put the magnet somewhere else, it shows you where to put the magnets. There's a little red dot on each magnet to show you the orientation. The red dot is up. The signal itself already comes with the magnets installed, and there you go. So that's it. Now, one of the things that, so let's talk about this one. This one's pretty cool. I just mounted on a single block so that I could just take this, literally put this out on the yard. It's got the battery in it, just like the other one, okay? And this one also, so anyone with a battery, I can take this cable and plug it in here. So this battery could run several of these signals. Probably 3 or 4 would be okay. And then you probably want a second battery. The other thing that all of these have is a little jumper here. And we have these brass strips. We're using our floating brass here. And this box, which comes with it, and the box goes over the top, slides onto those brackets, and there's the little light on the outside that shows you that the power is on. So it's pretty prototypical, and of course this goes on and off. So this is just completely stand-free, and we can trigger the lights. Let's see how far I gotta go out. Yep, there we go. And this box can be mounted separately like this, or it could be mounted on a single block and you just take it out. There's a little on-off switch right here, so I can just shut down the whole thing, or I can take the whole battery assembly out, unplug it, replace the battery. So that's pretty cool. The other thing that we included in this, because we were in the last stages of development, for N and HO, our precision sensors now have a push button on the back instead of the dip switches. And one of the things that we added was auto ranging. And so while I can take the provided screwdriver and adjust the distance where I want the detection range to be. I can also use the auto sensing, and the way that works is I just put it into auto sensing mode, put a train car out where I'm going to detect it. This will go into a flashing mode, take a picture, essentially a digital sensing of where the train is, and then that will be the range. And for G-scale, while we don't have varmint running around inside the cage here, I could imagine a squirrel or a cat running, going between the sensor and here, or on the other side of the track for that matter. They might not walk on the track, I don't know. But if you put it into the zone mode, instead of detecting the entire range from the sensor all the way to the train, it will only detect a 50 millimeter area, which is basically the rail distance. So if a cat walked in front of the sensor, it would not trip. Likewise on the other side. So that's very cool. And setting it, like I said, is pretty simple, either with the screwdriver here or by pushing the button. Again, all of the modes in terms of the aspects, there's you can get 2 aspects. So this is a 3-light system, so we have 3 lights. You can have ones that fade from mode to mode. There's a yellow flashing, there's combinations here. And so that's all included in the kit. And lastly, as I mentioned before, we have something called latching in our NNHO setup. And what that is after the train passes, if it's in the next block, you can run a wire from one signal to the other signal, and this will not turn green until the block ahead is clear. That's what we call latching. So that's available in all this. You can have forward latching, and you can have that latching daisy chain all the way around your layout. So that's the introduction of the G-scale. We do have several more products. So if you can anticipate what we have in NNHO, for example, the dwarf signals, that will be available this summer in G-scale. Contact us if you want more information there. And so this completes our range going from N scale all the way to G scale in all the lighting and signaling systems. Some of the next projects we have underway are for movement, and so you can anticipate what kind of things we have there. Oh, I should mention also that like the signal control, there's an output trigger on this. And so that will trigger our sound module. So if you wanted to have some announcement or bells or other sounds, barnyard sounds, as the train goes by one of the signals, you can just hook up one of our sound modules to that. You'd have to protect it. The sound module's not waterproof. We've had these outside quite a bit in the burning sun of Florida, and we'll continue to test them, but they've been very rugged and durable. We have kind of a weeping system so that any moisture that gets in weeps out the outside of the box here as well as over here. The sensor's been very durable. We haven't had any trouble with that, rain blowing and so forth. So we're ready to go, and look forward to your questions. Thanks for watching, and enjoy the